Hello, Mr. Long. This is FRQ number 6. So, part A is asking a free body diagram. I already drew the box. It's a little bit in an incline because that's what the problem shows. So, it's on a surface, so it's going to have an FG. It's on a slope, basically. So, it will have an FG. Or, I drew the FG the wrong way. It's going to have an FG, but since it's on a slope, it's going to have some components too. So, it's going to have FG of x, and also it's FG of x is pointing, by the way, this way, and FG of y is pointing theirs. Or since FG of y, I meant FG of x should be pointing this way. And so we're assuming in the problem, I'm assuming that the box goes up. So that's why I assume FG of x goes up. Since there is friction opposes this FG of x. So we're gonna draw friction opposing it. There's gonna be tension since it's being pulled up by a pulley. So there, and of course there's gonna be an Fn because there is an F of G. For part B, for drawing the magnitude of the expression, I'll do it right here. I'm going to say that I'm going to do Newton's second law, and I'm going to count all the forces on here. So on the force being acted, there's an Fg of x being acted too. There's also an Fk opposing this box too. So those are the three forces, and I'm going to assume that A is 0 because it's constant velocity. So A has to be 0. So, yeah. For I should label this as T, by the way, because of the free body paragraph. Sorry, not F, T. I'm going to assume also that T is just, I'm going to replace it with 2F because it's getting pulled, tension is getting pulled by two strings pointing up. So that's why I assume it is 2F, because this string is being pulled up by two strings here. So that's what shows 2F, because there's two strings being pulled up when you crop this string right there. So that's why I assume it's 2F. And I'm going to move this over to the other side. So and now I'm going to say also I'm going to put an angle right here. In the problem it shows an angle is right there, but this angle is the opposite because of geometry. So for my FG of x, since it's pointing this way, right? It's on the y axis, basically. So FG of x, instead of cosine, it'll be sine. And for f of k, we know that I should label FG of x equals to, should label this Fk is equal to mu times f of n, but the f of n will be cosine, because we're assuming this angle comes from that angle right there, and it's on the x-axis, and f of k is on the x, so we're going to assume that its f of n2 will be on the x-axis. That's why it's cosine. So we can write this expression in here that we just found for f of k too. So mu s mg cosine of, yeah. So then all we need to do, divide the 2 over to the other side. So and that will be our magnitude of the force. For part C, I'm gonna write the expression that we just found earlier. Since the angle is being decreased really, or both angles are being decreased, the numerator is gonna be lowered, which means that it'll lead to a smaller force. So if the angle of the ramp is this increase, this will help decrease. Technically, cosines also increase because when you, like, for example, let me draw like a triangle. If you decrease, assuming that this is sine, right? We're saying this is f of x. If the x decreases on a triangle, usually your y would increase more because geometry. That's geometry really. If your like cosine or sine thing decreases for your x, then your y should increase. But this is multiplied by mu, so that'll make this problem even smaller. This expression even smaller because mu is being multiplied. And usually mu is really small. It's usually under 1, right? So that means that this would be smaller, and also this is already smaller because your angle is decreasing. So it'll make it smaller. Your numerator would then be smaller, leading to a smaller magnitude of the applied force. So I'm going to say for this one that it decreases. For part D, I'm just going to label everything that we have. So our angle is 37. Our mass is, so that we don't need to write the units later on when we plug this in, 2.2. Our acceleration is 2.1 meters per second squared, with a plus sign. And our we're gonna use gravity too. That's just 9.8 newtons, and we're gonna take this line to be positive. So that's why I'm just gonna leave it positive. So we can use expression. We can use Newton's second law again. We can use the same for this force right here. We can use the force that we found here. We can use the 2F equal 2F. What was it? If we rearrange this again, we should get. We can rearrange. Instead of net force, we can rearrange like part B, T minus F gx minus F k that we found problem B to be the net force. So we can just write that, and we already assumed for part B also this has acceleration now, so this is not going to be 0 anymore. So we're just going to leave MA, and then we assumed in part B that T is also 2F, because when you copy, there's 2 strings on that pulley connected to this one here. Again, there is 2. So 2F, oops, I'm not supposed to put that. We can also rearrange it. 2F equals mg sine, like the previous problem. We're just, copying, just like shown here. We can just copy that because we already found these expressions earlier too. Equals MA. We can rearrange F equals what is it? We can do mg sine theta. We just move this over. And we divide by 2. So now we just plug in everything here into here. we just divide by 2 because move this over to the other side and then mathematically divide by 2 is just algebra. So that will give 5, 9.8 sine of 37. Ooh, 9.8. Oh my goodness, it's so hard to write. That's all right. I think the math. Okay, 5. Acceleration is 2.1. If you can read, it's hard to write with one hand. There, and then divide all that by 2. And now we just need to solve that. And we're taking the whoop to go this way, taking the whoop to be positive 2. So we should get, if you look at the calculator left side right here, 24.69. So, or can you round it? No, it's fine. And then, yeah, we take the whoop to be positive, so we take it to go this way, so we take the whoop to be positive. We're going to take it to go this way too. That's why we left a positive direction, which plus 24.68 newtons. Okay, so for part E, it's asking draw a free body diagram for both blocks. I'm going to start with the slightly easier one, which is the top box. So I'm going to assume it's on a surface, so it's going to have an FG. And like the f of g, it's going to have, since it's on a slope, it's going to have an g of x, of g of y. No, wait, I don't think so. It's alright. I'll just, oops. Because it's on the top block, it's not on the slope here yet. So it's going to be FG, and then there's going to be an FN. And also there's going to be an f of s opposing this too, because it's on the top block, and you know that top block is going to be a force of static, or in class we call that fric. There's going to be static friction pointing this way and this way for this top and bottom block for force of static. So that's why we put force of static here, because we're going to assume that you know what, let me just, no, I'm just going to put this back. I don't know why I wasted it. We're going to assume FGX points this way, so we're going to say, I guess force of static would point this way too, because it's going, yeah. So for the bottom block, I'm going to say it has N2 because it's on the surface. We're going to assume it has an FG2. Then it's going to have some components since it's on a slope. This time, we're going to put it up here because there is a top box. It has force of static. So that's why we're going to put force of static here. And there's tension on that box too. And also, since it's the surface has friction, we're going to assume that there is also an f of k. Because we assume the fg of x here is pointing this way, so f of x has to oppose it. Okay, so for part F, we're going to set up our Newton's second law, but for the small m, or the bottom m, the forces acting on this here will be tension minus FG of X is opposing that, plus f of k minus f of s. Not only f of k, k is opposing it, f of s is 2 because it's a stack box. Top box has f of static friction, or you can call it FRQ if you want. And we will say that the acceleration is 0 because it's on constant velocity. So then move everything to the other side, get t alone. We already proved from part B that t is also just 2f because you can crop the pulley here and it will show 2 f's pointing up when you crop it. Equals, we already established here that 2f equals this function right here, fg sine, because we just plugged in valid solutions into fg of x and of k, so we can also do that for part f like we did for part B. Or can, yeah. But also, this thing's going to have an f of s. Now, you might be asking, how do we find the f of s? This M right here has f of s opposing it, and it's only one box on it. So we can find f of s using making a Newton's second law equation just for this top box right here. Because there is static friction also on that top box, which will be way easier to solve for f of s. Equals to MA, things opposing this one right here. There's no tension opposing on the top box, but what's the forces on the M, or the big M, or top box is sine Fs because it's there, and Fg of x. Equals 0, and then yeah, Fs equals mg sine of theta, like we already figured out here. Fg of x equals mg sine theta. We just plug it back in. And we're gonna move mg sine theta to the other side, but we can just say that by the way, the top box is 3 kilograms, so that I don't need to like write units. So these are all units for part F, by the way, and part D also applies to it. Equals to 3, 1.8 sine 37. And oh, by the way, the reason why we subtracted this is because we're gonna say for the top box only, top box, the fg of x is pointing away from f of s, and we're gonna assume that it's pointing this way, and f of s is pointing towards this way too. So we're gonna assume that it's fs will be greater, and also that kind of makes sense too because you need the static friction in order to move what was it, we need static you need the static friction more second, my goodness, you need static friction in order to get this top box to like stick with this one, because it says assuming that it's not going to fall off. So we're going to say if f of s is bigger, because so that this top box would stay, we assume that, so that's why we're going to say its fs is bigger, so that there's enough friction to be, making sure that top box doesn't fall off. Hopefully that makes sense. I don't know if that made sense or not. But f of s equals so 69 newtons. And then we could just solve for, we can just plug all the values that we have already. So F, just assume that we divide 2, we just move the 2 over, but I'm just going to put all the numbers in now. And by the way, for the FK2, for the FK right here, we're just gonna put FK right here. Mu FS FN. The mg for this one, because mu s mg, that m is gonna be 8. Forgot the cosine. 30. Oh my god, this is painful to draw. 37, and then the mu will be, the reason why we put 8 is because we're not only calculating the Fn for the bottom box, we're calculating the Fn for the top box, because this bottom box is being, there's a top box stacked to it. So when you calculate the Fn and you use the mass, you have to use 5 plus 3, you have to use 8, because this m, there's a stack box onto here. This m is also being attached to another mass. So when we calculate the Fn for the f of k, we have to combine both of them to solve for f of k too. For just f of n, by the way. So 0.729, and then we just, what we just did here, we just put plus, we're gonna even have enough room. Yeah, we'll have enough room. And then we divide all of this by 2. So our net force will be 30.09, but we'll just say it's 30.10 if we round it up. So our force, 31.10 newtons, no direction because there is an absolute value sign on there. So yeah. Okay. So for the last problem, part G is asking calculate the minimum coefficient. We can start off by saying mu s equals fs equals mn, because that's a true expression. We already calculated fs through the previous problem, part F is 17.69 newtons. We say Fn equals 17.69 newtons. And the Fn, just for the top box, because it says what's the minimum stack friction, to keep the top box. So we're just going to assume just the top box is 3, 1.8, and cosine of 37, because Fn equals FG of y, because according back to the diagram right here, this FG of y, it's pointing down, and Fn is pointing, they're both pointing towards on the vertical axis. So that's why. And we use cosine because the angle here, or should be like around here, the angle's there, it's on the y, so fg of x now will be sine, and fg of y will be cosine. So we can just plug this back here over the Fn that we just found, or that we, and mu s will give you 0.75. 0.75. And that should be your answer. Okay, thank you for watching my last FRQ.